All right, you guys, welcome to day 2 of hyperbolas. Today I'm just gonna use my graph paper. It's a little easier for me to space my workout. Yesterday, hopefully you learned how to graph a hyperbola. Today we're just gonna practice that again, except I'm giving you the equation in this form. So you've done this for an ellipse. We just have to complete the square to get it to look like it did yesterday. It's a little harder because there's a couple negatives in there, but for the most part, it's pretty much the same as the ellipse. All right, so here's the deal. When you look at this equation, this is what you should look for. I have a y squared, I have an x squared. So if I have an x squared and a y squared, the shape it cannot be is a parabola. So then the question is it an ellipse or is it a hyperbola? And the way you can tell is that the coefficients in front of them are either positive or negative. So if one is positive and one is negative, that means it has to be a hyperbola. If this had both been positive, then it would be an ellipse. Okay, so I know I have a hyperbola already, even though the equation looks weird. Okay, so when you reorganize your terms, you always want to put the positive term first. So in an ellipse, we put the x first, then the y equals 1. Now you want to put the positive term first. So 4y squared is your positive squared term, so that goes first. Then you put the next y term, which is 24y. Then you put your negative squared term. Then you put your regular x. And then I'm going to go ahead and just put that 16 on the other side. Okay. All right. Now you have to complete the square. And remember, you always have to take out the number in front. So you have to take out the 4. Okay. Leaving you with y squared plus 6y. Okay. And then this is where you complete the square. So half of 6 is 3. 3 squared is 9. Okay. And then here you have to be a little bit careful. This negative sign right here does have to be factored out, and it has to be factored out of both of those terms. So that 4x turns into a negative 4x, okay? If you're ever wondering if you did it right, just remultiply. Negative x squared, negative times negative is positive, okay? All right, and then you complete the square. Half of 4 squared is 4, okay? And that equals negative 16. Okay. All right, now we're going to go ahead and balance this. So we learned this when we did the ellipses. We're not actually adding 9, we're adding 4 times that, right? Because everything in here is being quadrupled. So because of this 9, we're adding 36. Okay. All right, now this one, it says we're adding 4, but we're not actually adding 4 because everything in here is being multiplied by a negative sign. So the 4 is actually a negative 4. So you're adding negative 4. Okay, so really be careful of that. Everything here gets multiplied by that. In a hyperbola, this will always be a negative, so this is going to be the opposite. Okay, all right, then you complete the square. This factors nicely into y plus 3 squared. This factors nicely into x minus 2 squared. And then add these up. Negative 16 plus 36 is 20. 20 minus 4 is 16. Okay, just like in an ellipse, you have to have 1. Okay, and then you just reduce. 4 over 16 reduces to y plus 3 squared over 4. Okay, this is x minus 2 squared over 16 equals 1. Okay, all right, so now I'm going to go ahead and graph this. I'm going to set my axis. Okay. Sometimes I like doing my axis in a different color because there's so much going on in this shape. All right, so hopefully I have enough room. First thing is you always want to do is you always want to find the center. Okay, make sure you do x first. So the center is 2, negative 3. Okay, opposite of that, okay, which is right here. Okay, that's the center. Okay, and then again, just like in the ellipse, you use the numbers underneath the variables to determine the width. But instead of drawing an ellipse, you just draw a box. So underneath the y is a 4. So that means you go up 2, down 2. Underneath the x is a 16, which means you go out 1, 2, 3, 4. 1, 2, 3, 4. Okay, this would have been an ellipse, but instead you just draw a box around it because it's a hyperbola. Okay, so draw a box. Okay, draw asymptotes through the corners of the box. Right on the edge of my paper there. Good job. Okay. Okay. That's supposed to go through the center. I missed it a little. Okay, and then here's the really, really important part, okay? When you go to figure out, when you go to actually draw, you have to look at this. Since y is positive and it comes first, my hyperbola is going to have vertices parallel to the y-axis, which means this is a vertice and this is a vertice. So my hyperbola goes like this. Okay. All right, so just be really careful of that part. All right, and then you do always have to find a couple more things, right? You have to find the foci. Let me move this up a tad. Okay, so the foci are going to be here and here because they're always inside the shape, okay? And remember, c squared equals a squared plus b squared, okay? In an ellipse, A is the biggest, but in hyperbola, C is always the biggest because the foci are outside. So you just take these two, remember, add them up. So c squared equals 4 plus 16. Remember, those are already being squared. C squared equals 20. So the distance to the foci is root 20 or 2 root 5. Okay, so root 20 is like 4.5. So you go 1, 2, 3, 4.5. Foci. 1, 2, 3, 4.5 foci. Okay, and then I do want you guys to write those exact points because they're kind of weird. You know that it's 2 over, and then from the center, which is -3, you're going to go down 2 root 5. And then here we know it's 2 over, and from the center, which is a -3, you add 2 root 5. Okay, all right, so we're almost done. Hey, don't forget that you have to find the equations of these asymptotes right here, okay? So the equation says it's y minus k equals plus or minus the slope times x minus h. Because remember, the point always goes through the center, okay? So the center is right here. The center is 2, -3. So that's going to be y plus 3 equals plus or minus, because there's 2 lines, of course, okay? When you find the slope, you just do rise over run, okay? So the rise is right here, that's 2. The run is here, that's 4, so 2 over 4, okay, which of course reduces to a half. So the slope is 1/2 x minus 2. Sorry, I lost my train of thought. All right. So I know there's a lot of steps, but that is how you graph a hyperbola when it's given to you in that form. Okay, so if you don't need another example and you're good to go, that's fine. If you want another example, I'm going to do one more example. Okay, all right. Sorry, hold on. Gotta get my tape. Okay. So this is the problem I want you guys to do. So I want you to just take a second and write, oh dear. Wow. Okay. I want you guys just take a second and write that down. Okay. So on this problem, again, you know it's a hyperbola because x is being squared, y is being squared, but one of the coefficients is negative. So when you organize it this time, x squared is going to go first because it's the positive term. The y is going to go second because it's the negative term. And then the 4 goes on the other side, okay? All right, now you complete the square. X squared plus 8x, okay? Half of 8 squared is 16. Here, make sure you take out a -3. Probably the most common mistake is this sign right here. If you take a -3 out of a -6, you are left with a +2. And then complete the square. Half of 2 squared is 1. Okay, and then remember, I added 16 here, so I add 16 here, okay? I added 1 here, but I actually added -3 here, okay, because 1 times -3, okay? All right, and then you factor. Okay, and then you add, that's 12, minus 3 is 9. And then, of course, it has to equal 1. So our equation is x plus 4 squared over 9 minus y plus 1 squared over 3 equals 1. Okay, so let's go ahead and graph this guy. Draw my axis. Okay, So again, find the center first. Okay, the center is always xy, so be careful that x is -4, y is -1. So 1, 2, 3, 4, -1. Okay, all right. And then you want to just look at the directions. Okay, so in the x direction, you're going to go out 3 and out 3. In the y direction, you go √3, which is about 1.7, and then you draw your box. Okay, and then you draw your asymptotes. Okay, all right, and then again, make sure you're really careful about this part. This is what determines the shape. Since x is positive and x is first, it makes this a vertice and this a vertice. So our shape is going to be this direction, like this. Okay, all right. And then, of course, you have to find the foci, which you know are going to be out here. Okay, so the distance to the foci squared equals a squared plus b squared. So the distance to the foci squared is 12, which makes that √12 or 2√3. Okay, so the distance to the foci, you go out 1, 2, 3, and a little bit. 1, 2, 3, and a little bit. Okay, my hyperbolas didn't quite hit the vertices, so it looks funny. Okay, make sure these go all the way to the vertex. Aww. Okay. All right, those points are from the center, which is at -4. I add 2√3 and go down 1. And this focus right here is from the center at -4. I subtract 2√3, go down 1. Okay. Oops, sorry. Let me move that up. There we go. Okay, and then one more thing. Equations of the asymptote is y minus the y part of the center, so y plus 1, plus or minus the slope is rise over run. So you rise the square root of this amount. So you rise √3, you run the square root of this amount, which is 3, and then it's x plus 4. All right, group. So try your homework, email me if you have any questions. And we could also talk about this more on our Zoom meeting, which I think is going to be on Thursday, but I'll post it on my website. Okay, bye, you guys.